Okay, well, welcome everybody to our sixth Scalable Pandas Meetup. I'm so excited. This is going to be so much fun. Really grateful to have Niels Bantilan here today and for us to talk about validating data frames with Pandera and then also just data validation more generally. Okay, so first, the agenda, we'll just really quickly talk through why do we have these meetups. We'll do some very brief introductions in the chat, and then we'll move on to the main event. Okay, so what are these meetups about? So this is our sixth meetup. We're holding these to talk about challenges that arise when you're using really large data sets with in pandas, and when you have really complex workflows, and then talk about solutions to those challenges. So this is a place for coming together to look at case studies, different tools, best practices, and sort of commune together as a data frame loving community. Who is Ponder? Ponder is the enterprise-ready pandas company. We're the primary developer maintainer of the open source library Modin, which has over 4 million downloads. It's a drop-in scalable replacement for pandas. Why did Ponder start these meetups? We're trying to build up a collection of content and learning materials surrounding this question of using pandas at scale. How often will these be held? These are typically held on the fourth Thursday of every month. And then how can I get involved? If you'd like to get involved, you can email me at peter@ponder.io. Really thrilled if anyone's interested in being involved. Okay, so I get to introduce Niels. I'm really excited about this. So Niels, chief ML engineer at Union AI. They're building next-gen tools. I guess I should say this so that Union AI gets more airtime. To make data and ML-driven software more reliable and reproducible. And I looked, and there's actually several different projects under the Union AI umbrella right now, and one of which is Pandera. So that's kind of cool to see that, like it's got this ecosystem. 8.5 years in formal data science ML roles. Spare time likes to train whimsical models. Also, you should know that I think this is so cool, Niels, that you studied as an undergrad biology and dance, and that you were on like a dance squad for the Cleveland Cavaliers for a time. Like that is so cool. I think that's extraordinary. I love that. Niels also has a master's of public health from Columbia, but has now been in data science roles for a long time. But anyway, at some other point, maybe even right now, but I would love to hear more about the dance part. But so I'm excited to introduce Niels, and today he's going to talk about validating your data frames using Pandera, which Niels will emphasize is a very personal relationship.
Thanks, Peter. Yeah, we can definitely chat about dance. I still do it these days, but less so after a series of injuries, as it happens. But yeah, thanks to everyone for joining here. I'll be talking about data validation using Pandera today. And I'll try to give you a little more context, I guess, on like the motivation here. I'll skip this background, but so Pandera was something I built as a side project 4 years ago, and this is kind of like the main question I was asking at the time. Side question was, can I type annotate my data frames? Since I think type hints were like a new thing back then. So, as a data scientist, ML engineer, more broadly a data practitioner, how do I make my pipeline robust to data errors? And for any of you who work with data, probably all of you, you're all familiar that corruption and incorrect implementations of code that lead to data and reports and models can lead to errors that silently pass, and so you'll have values that aren't what you expected, and then they kind of corrupt your deliverable, be it an analysis or visualization. These are just two of the places where things can go wrong. And so I set out building this tool that, if each of these boxes is a function in a pipeline, you can kind of like guard the inputs and outputs of it, where those inputs and outputs are data frames, pandas data frames, to be specific. And so I started building this tool, and just to level set with everyone, here's a little view of what a data frame looks like. It's basically a table. But data validation is something that I've been sort of like I had been doing in Python, just like making my own assert statements and stuff. But it wasn't until I looked up, the literature. I'm missing some citations here, but there's work done that kind of frames data validation as the act of falsifying data against explicit assumptions. So if I make this claim that all swans are white, to confirm, I can take the approach of confirming that claim, going out and like doing the impossible task of finding all swans and confirming the color. Or I can find the first instance of a black or a purple or a brown swan, and then now I need to refine my hypothesis, right? I need to change my assumptions about the world, add some conditionals in there to like say most swans are white or something like that, right? And so over the years, the lessons I've learned building Pandera and just working with data in general is that the better you can reason about the contents of a data frame, the faster you can debug. The faster you can do that, you can focus. The faster you can focus on other things. And also a nice, I wouldn't say side effect, but an actual outcome that happens is if you make your assumptions about data explicit in code and enforceable in code, you're enforcing it at runtime, right? But you're also creating documentation for the rest of your team or yourself in the future. So returning to this question, is data validation enough though? And I would say that maybe these two things aren't sufficient, but they are necessary, I think. So data validation is a key piece, but we also want pipelined validation. And so what I mean about that is, data testing is not only validating real data as it's coming in from the real world. So you're protecting your internal system from the craziness and the, all the things that can happen outside of that. But you also want to test the functions that produce, say, the downstream data that you're dumping into a table or in your data lake or whatever. And this visual is suggesting to you that I can take this raw schema that was testing the real data coming in, but I can actually use that as a set of properties to generate synthetic data that I can then feed into my pipeline in my unit tests. So I can kind of start building confidence in the code that produces the downstream data that I use, say, in my company. So now I'll jump into a short demo. I don't have too much time. I have 5 minutes. So hopefully I can give you a little bit of a flavor. But these days I'd like to frame Pandera as a data testing and statistical typing tool for data science, ML, data engineering oriented data containers. I'm not going to get into statistical typing. That's a whole another can of worms. But so if you go into the documentation, there is this try Pandera thing, and that's a Jupyter Light widget. You can check it out. You can click here to actually go into like a Jupyter Notebook environment. But here it is. Hopefully this is all working. Okay, because the demo is not applying to me today. Okay, so this is a brief introduction to how Pandera looks. So if you're familiar with Pydantic or data classes, the way you express a schema in Pandera is by creating a class that inherits from schema model. Let me zoom in here. And here you can see a very simple data set of items that can either be apples or oranges. The underlying data type is a string. And each item is associated with a price of type float. I know I'm aware that you typically you want to store prices or any kind of money as integers, but anyway, let's just sort them as floats for now. And the price has to be greater than 0. So that sort of makes sense. And by specifying these coerce equals true arguments, I turn the schema into a parser as well. So what's going to happen is I'm going to get the raw data. I'm going to try to coerce the data types into strings and floats, respectively. And then I'm going to apply a bunch of constraint checks to see whether the actual data values conform to the schema. So typically the way you want to use this, kind of in production or how you integrate it into your existing, Python code, is to define a function with a type annotation here. This data frame is a Pandera specific type that's a generic where you can supply a schema argument to it. And I've added this check types decorator for lazy equals true. What lazy equals true does is it'll actually try checking all the constraints before raising an error. if it's false, then it'll raise an error, the first error it encounters. So the data frame is obviously empty right now, but what's going to happen when I call transform data that's check types decorated is it's not going to do anything, right? So nothing actually happens. Maybe if I return the data here, it's going to actually just return the data itself. So that's fine. So that's how schemas work if your data is valid. But if your data is invalid, then I'm going to catch the error that I know is going to happen because I've introduced this negative number in the price column. And you can see that it raises an exception. And this exception exposes a failure cases attribute that actually gives you a granular view as to what exactly went wrong. So I had an appley typo here, and I had a negative value here. And it tells you which index in the original data frame that the error occurred in. Gives you a little bit more metadata about which checks and which column these things occurred in. But as you can see, this is a very developer-centric, like data science, like person on the ground working with the data type framework. So it gives you kind of like these very basic structures when things do go wrong. And you can, people who using Pandera will take this failure cases data frame, create their own custom reports, do all sorts of things. There are a few issues on GitHub to like spruce this up a little bit, but this has been working fine so far. The cool thing about this syntax is that you can actually express transforms like declaratively, sort of like this, where I'm inheriting from schema and defining this new transform schema, which means that I'm going to inherit all of these attributes and then add an additional attribute. So inheritance semantics of Python take hold here. Basically, you can imagine the function that implements the transition point between these two schemas. And here it is, right? I have a function, takes in the schema data frame, and I'm going to assign some expiration dates to these items, right? And so this is a happy pass. This worked fine. But if I have a typo, right? So if I misimplement my function, Pandera is going to complain. The column is not in data frame. The column is the expiry, but actually I had a bug here. This will apply to much more complex, like in a realistic setting, much more complex transformations and expectations around the transformations, input and output transformations. I'm going to skip this object-based API just to give you a little hint of it. This is actually the OG flavor of Pandera, is the object-based API. These are the two equivalent ways of writing them. The main benefit of this schema object is that you can transform them on the fly. So it's more imperative. You can add columns, remove them, update the constraints, etc. The last thing I wanted to show you off here, actually, which ties into the testing the functions that produce your data part of data testing, is that let's return to this transformation function. And I have the bug here again, so let me just redefine these. So what would the unit test look like for this, right? So typically, if you didn't have Pandera, you would get the output of this function, and then make a bunch of assert statements on the unit test. This is the Pandera unit test. So I'm using hypothesis. There's a little background here needed to really grok this, but basically you can think of this hypothesis.given data equals schema.strategy is I'm going to generate pandas data frames of size 5. And just to prove that it's doing stuff, I'm just going to print this data variable here. And this becomes an execution test. Because transform data does runtime type checking already, it's going to complain. So as you can see, it's generating a whole bunch of valid data under the constraints of my schema. It's going to try falsifying this claim that I have that, this transform, and then it's going to complain here, like column's not in data frame. So now I go up, okay, fix the bug. And then now my test passes. I can configure this with max examples. So I can give it 10 examples. It's going to try 10 times to falsify my claim about this function, and then it's gonna be satisfied and say, okay, this is a valid function. So there's a lot more to this. The last thing I'll say here is, since this is a Ponder meetup, here's the mode and integration. It's exactly the same schema. So yeah, it's fairly magical. It was a lot of work to get this to work properly, but the integration itself was fairly seamless. I didn't have to special case too many things. And so with that, I'll end my presentation. Thank you.
Okay, thank you so much. Okay, I have so many questions, and then the audience, we'll have plenty of time for audience questions too. But I'm going to sort of exercise moderator privilege and selfishly ask a couple of my own first. In some ways, you have to understand like the decorator usage and classes and objects, but on some level, you've done a great job of making it sort of beautifully straightforward, I think. And but I think in many cases, an end product like that sort of hides a lot of complexity. So I'm interested, what was the most challenging thing in building out this system? I guess expected or unexpected.
Yeah, I mean, this is sort of like, I think of the science paper analogy, like you do a bunch of experiments and things are super nonlinear. And then when the paper comes out, it's like this nice little story.
Yes.
So the thing I just showed you, right, is like a refinements over 4 years. I think the most challenging part was the data synthesis part of this. So I didn't show this, but if you call schema.example, it's going to just generate a schema data frame for you that you can manipulate yourself outside of the whole hypothesis thing. But yeah, I had this fairly stable API for the schema specification. And then I already had been using hypothesis for other stuff. You can use it for any arbitrary Python property-based tests. But to write all of the code and logic around like how to translate the Pandera schema into a hypothesis strategy that actually conforms to the schema's constraints, it still is kind of like a big challenge. There are a lot of inefficiencies in there and schemas that just won't translate. So it's just going to raise an error saying like, I can't, there are too many things in here that I can't fulfill.
Yeah, okay, that's so cool. And I guess for the purposes of helping the Pandera project, is there some aspect of it where like a person with a particular set of expertise or background to contribute to the open source, you'd be like, hooray, like this kind of background is like ideal for, taking Pandera to the next step? Because maybe there's someone in this room or someone who watches on YouTube who's like, oh, I'm good at that.
Yeah, no, that's a great question. So one of the things I've been thinking about lately is, and I'm working on, is rewriting the core internals of Pandera so that it abstracts away the Pandas specific stuff. Because if you think about it, Pandera is simply a way of defining the schema. And the way, it was built out initially, and this is like, I was not prematurely optimizing for just like schemas for everything, is that the schema specification and the thing that actually runs the validation with pandas, they're kind of interleaved. And so to like support, when it kind of gets to this question of, Modin is a drop-in replacement for pandas, there wasn't too much. There were like maybe a method or two that weren't implemented, I forget at the time, but there were like reasonable workarounds. So I think expertise of someone that would really help the project would be people who are familiar with projects like Polars or Vakes, other Xarray. There's actually an Xarray schema that's modeled after Pandera that's a separate project. So I'm talking with those folks. But it's going to be a challenge to figure out what the right abstractions are that fit all of those kind of different APIs, and how to manage the variance, and like obviously there will need to be special classes or different constructs for certain things, but pull out the commonalities, and getting feedback on the design there, and actually like implementing the backends for those various other data frame containers will be, that'll be a big help.
Yeah, cool. That's cool. Well, let's hope the dreams come true and someone's watching this on YouTube and they come your way. So on the subject of support so you have support for Dask, for, of course, Pandas, Dask, PySpark, Modin, DataFrames. I saw that at one point you had Koala support, but have since deprecated that. I'm very interested in what you learned about these different data frames as you were going through this process. Like you have there's a small community of people, I think, in your shoes who have worked closely with all of these kinds. I'm interested in some of the things you've learned.
Yeah, I mean, I think so. The one thing that we have another integration with Fugue, which is it's not exactly a data frame. It's closer to just like a distributed compute kind of framework. So you can use various backends to that work well with pandas. So you can distribute jobs like that. But the thing that the creators of that project like to say is, it's like the assumptions that Pandas has in its API doesn't necessarily, like, assumes in memory, like the data is all in one place. You can kind of like grab any subset of it and it'll all kind of be close in memory or in the same kind of location in memory. Those assumptions don't hold true with in the distributed setting. So, I mean, this is something I didn't have personal experience with integrating with Pandera, because I got lucky. Like the subset of pandas that it did use worked well across all of these different libraries. So I was just like, okay, so I was anticipating a lot more hardship here. But I only had to special case a few things, as I said earlier. But I mean, the one lesson is interesting, like the process of designing software, like there is like this, going back to my biology background, there are like conserved traits, right? They're like things that we build on top of kind of things that have existed that we don't change because, we want to optimize for other things like usability, and, we don't want Pandas users to like learn another new API to sort of like migrate their code. But at the same time, then there's like a little trade-off there of certain operations in Pandas will likely not work. Index-based stuff, for example, won't work in a distributed setting like as easily. But fortunately, as I said, Pandera doesn't rely on sort of like picking out various indices in a data frame. It will sort of just validate the entire thing, which is what Modin and PySpark and all these other projects do well. So, yeah. Yeah,
that's nice to hear. That'll make it much more maintainable too, as all of the systems upgrade. Okay, so a couple more questions, then I'll turn to the audience. But so my guess is in the audience today and those watching online, there will be a distribution of sort of familiarity with Pandera specifically and with data validation generally. So could you help situate how Pandera fits into the broader ecosystem? I saw on your website, on the GitHub, you very generously linked to other validation tools, which I thought was magnanimous, including Great Expectations. So I'm interested in Pandera and Great Expectations, and then DBT now moving into the Python world. And DBT has some sort of like assert functionality built in, uniqueness, and there's a bunch of things. How do you think of Pandera, Great Expectations, and sort of DBT? When should someone use one or the other?
Yeah, so with Great Expectations and Pandera, I like to make the analogy that Django is to Flask as GE is to Pandera. Like Great Expectations is batteries included. It has a UI, you can edit your schemas on there. It has like visualizations. You can configure various different databases and stuff like that. So it's super feature rich. It has a lot of built-in validations. In contrast to Pandera, which doesn't have many built-in validations, but it is very easy, if you know pandas, to just write your own custom inline checks. And so that's what I sort of had designed Pandera to be zero configuration, just data validation as code, sort of keep making the schema and the thing that validates your data as close to the code as possible. Just, my take as someone who's worked as a data scientist and ML engineer and, munged a lot of data, like the further away that schema is from the code, the more you're going to have to like know where it is and maintain that, and sort of like, so that's why that's sort of like the design philosophy of Pandera. It's always going to be code first, and kind of follow all of the Python conventions and make it as easy as possible to write it with regular Python constructs. That schema model thing was the second iteration of the API, very much designed after Pydantic and data classes. So I guess that would be the difference between those two. I think larger teams with like many more stakeholders who are not technical should probably use Great Expectations. Which is not to say that I don't think about like a UI and something in the Pandera project, but so since Pandera is now an open source project in Union AI, I consider like that multi-stakeholder, like an executive or a product manager wanting to look at the state of like what we consider valid data. I consider that to be kind of a separate product from Pandera. So no movement on that yet, but I have been thinking about this. And with DBT, I haven't really used it. I think the audience, I see the value of modularizing SQL and templatizing SQL. Moving into Python kind of just means I can make an integration. So not sure if it would resonate with DBT users, but it does have a declarative YAML spec, so you can write your Pandera schemas in YAML. It doesn't give you as much power, so you can't create your own custom checks, but that it is there. So yeah, I mean, I think Pandera is definitely a lot more like developer focused and like code first. Short.
Yeah, that's great. Thank you. That's super helpful. Matt had a question, Matt Harrison. Matt, do you want to come off mute actually, if you're in a position to do that and ask, or I can just ask for you?
Yeah, so there might be noise in the background, but yeah, so I mean, Pandera does a lot of things, which is awesome, but like if someone is just getting started, where would you like say, like, if you do this first, you'll get the most reward for doing this? I mean, I would imagine that like jumping into hypothesis, using that might be a lot of work and might not necessarily tell them a lot per se versus some of the other things.
Yeah, the key thing I like to say is identify the critical part of your whatever pipeline you're working with right now. So that if that's like the database read, if you're reading a query from a SQL database into pandas, if you're reading a file from a blob store to train a model, like that's the one checkpoint to write a schema for. And that typically that's
the boundaries around the boundaries.
Yeah, the input-output boundaries of your system with an external system is probably the most important part. And then the second bit would be, like say you're training a model and you've done a bunch of data processing, like non-trivial data processing on that raw data, whatever that model or analysis ready clean data is, like another checkpoint there. And so kind of like these two checkpoints are like the key pieces to cover. Yeah, admittedly, hypothesis is, once you've seen the value of it and you want to like sort of add that to your unit tests. So.
Can I follow up on that?
Yeah.
So a lot of, like ORMs will have a notion of like schema migration, right? Have you given any thought to that? Or I mean, a common thing I hear around just Python and pandas code in general is like, how do you world's going to explode when something changes, right? This code is not serviceable, right? And so what's your take on that?
Yeah, I mean, I know from one set of users that I think I forget where they migrated from, but they started using Pandera because it was just a lot more maintainable. To update your schemas as something changes in the world, and the data set changes, maybe there's a new label, a new category in your training set. But when it comes to like migrating a SQL table and reflecting those changes in a Pandera schema, I haven't seen that use case in like issues or questions yet. So I haven't given it too much thought, unfortunately, but it would be an interesting thing to like pull out the metadata from like a migration framework and translate that to Pandera schemas automatically.
Cool, thanks.
Yeah.
If anyone else has questions, you feel free to ask them in the chat, and then I can have you come off mute, or I can read them while that's happening. So another question is, I was talking to a friend of mine who works in sort of data validation space, and he said there's this interesting phenomenon where kind of what we were discussing here, where you get data testing that bunches at handoffs. And the vibe I got was sometimes this is defensive. It's like, test the data right when you get it as another team hands it to you, because you're like, aha, this is not our problem. Like, it came in broken, like you've got to fix it. I'm curious about the sort of your take on the sort of organizational, like what interpersonal problems data validation helps with in a sprawling organization.
Yeah, I mean, wherever your source of truth is about the schema of your data, like the Pandera's opinion on this is it should be in code. So I can see, I'm just making the story up, but I can see a company with two teams where the second team that's getting the data is like kind of suspicious. But then team one is like, oh, but here's the schema and here's the workflow execution that like created this data set. And oh, look, it passed the schema check. And so team two is not going to have to rerun that validation on the data that's coming in. So I mean that it kind of will alleviate this and provide a single source of truth that people can gather around and say, okay, here are all of my assumptions. Team one puts all their assumptions, and then team two is like, wait, no, but here are some other assumptions we want. So then, because Pandera is a Python object or Python class, you can reuse it, right? So you can make it like an internal installable package that both teams can install and like be happy using. So team two could use schema as a generative thing, so they can test their code even before the real data comes in. And then team one can be developing their processing pipeline and then just making sure that it's valid under that schema.
Yeah, that's great. That makes sense. Yeah, if anyone has other questions, I have so many questions. I'm really excited about this. I was a data scientist at Coursera, and like I didn't do this isn't a reflection on Coursera. They have excellent data scientists. I really didn't do data validation, particularly in informal ways. So I've like recognized this as a gap in my knowledge base for a long time. I would sometimes do unit testing and things, and sometimes generate a data frame, pass it through, make sure this, particularly when I was uncertain about like an R pipeline or something. But anyway, so another question is about like the vision for Pandera in 5 years. So, okay, Pandera is what it is right now. It's exploded in the past year. It seems to me like it has over 5 million downloads now, and it's more than doubled its GitHub stars in the past year to 1,700. Like it seems to be, the trajectory is an amazing one. What would you love to be different about Pandera in 5 years?
Yeah, it's this project that I did not expect to work on for such a long time. But is like, I've had there's like a graveyard of like open source stuff that I've started that, I've just abandoned. Right. But, in the next 5 years, I really want to get more support for other DataFrame-like containers out there, the ones that maybe don't even exist today. And also support and, kind of make it a ubiquitous thing in the different orchestrators out there, so there's Flight, which is what the Union AI team is working on. There's Dagster, there's Prefect, there's Airflow. So kind of having coverage of the different orchestrators and supporting Pandera there, I think will kind of just help. Like the easier it is to write that schema, the more likely it is that a data scientist at a company will validate their data. And yeah, for the longest time, I did not validate my data, but so many times dates would be strings or weird things would happen that I just saw the value in it. And I think the support for other containers and the orchestrators, like, I think that'll be enabled by, I myself want to invest in community and the ecosystem. So, make it really easy to extend and write your own custom backends for your own arbitrary objects. And B, just support the community in like a contribution type of ecosystem, package ecosystem type setting where, Pandera as a code base is getting larger and larger. I don't think it makes sense to have like a Polars kind of like support for it in that code base, but like to have an ecosystem of like contrib packages to support these other non-Pandas API compliant frameworks.
Yeah, thank you. That makes sense. And we have Elijah Ben-Izzy here today from Hamilton. I would love a world in which maybe it already integrates really well, Elijah. But I can easily imagine a world in which you're, validating all of these, the functions that are sort of the backbone of your Hamilton, driver experience. But
yeah, I mean, we built a whole Pandera integration as well that we're pretty excited about.
Awesome.
We have a data validation, and then we've got a and it's all like inheritance and nice. And then there's a little subclass that's Pandera. So all you have to do is pass in a schema and then it can validate it. Neil, you probably tried with this one before. We're happy to talk and sort of walk you through how we're using it.
Yeah, cool. That's cool. Okay, well, so we're almost out of time. We have one final question from Matt about schema standardization. Matt, if you want to ask this one, and then we can pull it to a close. But yeah, I'll say some final words just after that.
Yeah, I think one of the nice things about SQL is that there's a standard, right, of DDLs, and you can sort of take that and you can kind of run on different databases, right? Whereas in the sort of table as a programming language world, there's sort of the Pandas API, but people deviate from that or whatnot. I think meta commentary would be nice if there was like a Pandas API standard, but like on that note, like because we're basically talking about two-dimensional tables, right? Has there been any thought about like making like a JSON or YAML or some other maybe XML representation, right, of a schema that's not necessarily Pandera specific, but like that, once people have a schema, then they can throw it around in different tools, or Pandas can validate it too, or any thoughts or ideas around that?
Yeah, so I actually just spoke with Travis Oliphant about this, about the DataFrame interchange protocol that's just linked literally in the chat here. So that's about a kind of standard DataFrame protocol, but in terms of schema standards, I think there is a project that uses JSON schema and extends that to DataFrames and like columnar data structure formats. I remember looking into it. I forget why exactly I didn't end up using it. I think it was just, it was like going to be a heavy lift to get Pandera compliant with that. So these projects are around for sure. There are probably a lot of like more social like governance processes that need to happen for like people to like coalesce around a standard. But there are, you can kind of see prototypes of it here and there. So Yeah, I would love to get involved. I mean, if anyone's watching this after the fact, to get involved in any project like that, really cool to get involved.
That's great. Yeah, Matt, thank you for the question. Niels, thank you so much for coming today, talking to us about data testing broadly and data validation within that. So interesting. I learned a lot. I'm really excited about this. And thank you everyone for attending.
Awesome. Thank you, Peter. Thanks, everyone.